Hi Algebra 2 students. I just wanted to make a quick video for you guys going over the front of this worksheet just in case there's something you're not quite understanding as you go to try to finish it for homework. So the first thing we had to do is kind of sort through these characteristics, questions, and processes and see what part of this picture do they go with. And we have a dolphin jumping out of the water and coming back down, which is clearly a parabola. And then we can kind of think, it says our x represents the horizontal distance the dolphin travels, y represents the vertical distance. So it could be helpful to kind of, if we use the water line as our x-axis, and then if we kind of assume that the y-axis is from where the dolphin starts. So that is my x-axis, my y-axis. Okay, so first of all, the x-intercepts here should be obvious where the dolphin is coming out of the water and then hitting the water again. So I'm going to put an A next to both of those spots. My axis of symmetry, I see my vertex right there. I know my axis of symmetry goes through it. So that's my B. And then C, my vertex is up there. So how do these questions then relate to these different locations? What is the dolphin's maximum vertical height? Well, that's always going to be the y value of my vertex. So I'm going to kind of put number 1 up here with my vertex. At what horizontal distance does the dolphin reach its maximum height? Well, that's this x distance going from my first x-intercept over to the axis of symmetry. I'm going to put a 2 right there next to my axis of symmetry. I also know the axis of symmetry is also the x value of my vertex. And then 3, how far away is the dolphin from his starting point when he hits the water again? Well, it's going to be my x-intercepts, but it's only one of them, right? It's the second one over here because my first one is where he starts. Okay, and lastly, we're going to match a process. So process 1, or I, is x equals negative b over 2a. Hopefully by now we know that gives us the axis of symmetry. Then this notation is f of negative b over 2a. So the idea is you're plugging the x value you get here, and you're plugging it into the function for x and evaluating. And that would give you the y value of the vertex. I'm going to put double I up by the vertex. And then lastly, we have the quadratic formula listed, which is one way of finding the x-intercepts. Because remember, the quadratic formula will give you the solutions to an equation if we have 0 equals ax squared plus bx plus c. And we know that the x-intercepts are where the y value equals 0. So we know this formula will give us the x-intercepts. We could also potentially try to factor, complete the square, solve using square roots, depending on what the equation that models the situation looks like. So sometimes it might be possible to use one of those other methods, though quadratic formula is always a good backup plan for whatever the equation you're given. Okay, so now let's see how using these processes to answer these questions works. Question A, at what horizontal distance does the dolphin reach its maximum height? So based on the way we labeled the picture above, we know that I should be using negative b over 2a to get my axis of symmetry to answer this question. So I'm doing negative 5 over 2 times negative 0.2. And that's going to give me negative 5 over negative 0.4, which is 12.5. So we know the horizontal distance is 12.5 feet. I didn't actually give you units here, but let's assume the units are feet. Okay. So now, what is the dolphin's maximum vertical height? That's going to be the y value of the vertex. So I'm going to take 12.5 and plug it into the equation. Okay, so using a calculator to actually evaluate this, I get that we have 31.25. So that means that the dolphin's maximum vertical height is 31.25 feet. And then lastly, it says, how far away is the dolphin from his starting point when he hits the water again? Going to think about this equation being set equal to 0, right, to find the x-intercepts. So if I'm plugging into the quadratic formula here, I'm going to have x is equal to -5 plus or minus the square root of 5 squared minus 4 times -0.2 times, now if I notice in this equation I don't have a c value, right? So the idea is the c value in the equation is 0. So that means I'm putting a 0 in for c. All over 2a, so 2 times -0.2. So if I start simplifying, I know that 4 times -0.2 times 0 is just going to be 0, which kind of simplifies things. So I get -5 plus or minus the square root of 25, since 5 squared is 25, all over -0.4. So continuing to simplify, that gives me either I have -5 plus, the square root of 25 is plus or minus 5, right? So I have -5 plus 5 over -0.4, which gives me 0, because -5 plus 5 is 0. And then if I do the minus situation, I have -5 minus 5 over -0.4, which is -10 over -0.4. So I get 25. Now you might think, well, I have two solutions. Which one is the answer to the question? So if you come back and think about it graphically, if we have 0 and 25, well, clearly this first one is the point 0, 0, right? So that's my first x-intercept. So my second one must be the 25. So to answer this question, how far is the dolphin from his starting point when he hits the ground again? He's 25 feet from his starting point. So now I'm going to leave it up to you to try out these same processes on the back. One slight difference on the back in the problems is on the front we were thinking about our x values as a horizontal distance going like this, but on the back the x values are actually t values and they represent time. So we can say at a specific time we know that there's a certain height of the function. So do the best that you can, and we'll definitely be talking about this next week. Have a good weekend.